downward. The works are based on non-destructive engineering techniques and include diversion ditches on the slope top, ditches for spurting liquid, etc. Because the main cause of landslips is the concentrated water flow, we cut off the water and safely induct it so as to prevent the slope surface from being eroded and collapsing. Meanwhile, we reinforce the vegetation on the slope to avoid erosion. The restoration project of natural creeks is focused on the prevention of landslip and sediment deposition that would threaten the catchment area of reservoir. The installation of anti-sand dams is also an important part of restoring the catchment area. An anti-sand dam, a continuous low dam mainly located on natural creeks with steep upstream beds, can avoid scours that deepen the stream beds horizontally and also prevent possible landslips that generate a large amount of debris. From the DVD footage, courtesy of Songhe Animation Company, we can clearly see the debris flow through the anti-sand dam that will adjust the gradient of the slope, stabilize the water flow, reduce the amount of debris rolling downward, ease the deepening of stream bed due to scours, and contain the landslips. When the anti-sand dam is silt up, the slope becomes less steep and water flow begins to slow down. The debris buildup can stabilize both the foundation of landslip and stream bed so as to avoid the formation of debris, because the purpose of an anti-sand dam, a ground sill facility that measures more than 5 meters in height, is not to stop or collect the sand. It will not clog up with the slow deposition of sediment. The aerial view of the simulation shows us the predicted results of restoration project. Baoliku Creek, a tributary of Dahan River, saw many landslips caused by typhoon air. In order to contain the debris from these landslips, preventing it from flowing into Shimen Dam, and avoid further collapses of the creek due to scours, we installed 5 ground sill works in the downstream section. A tributary of Yufeng Creek, Taiping Creek, has many landslips along its banks. To prevent the fallen debris from being flushed into the reservoir, we will conduct rid vegetation works at the landslip sites and install several anti-sand dams on the stream bed so as to stabilize the bed and avoid further deepening. During heavy rains, debris flows are often seen on the Sul Natural Creek, a tributary of Dahan Creek, and erode the downstream section, widening and deepening the stream bed. Hence the severe landslips on the upstream slopes. The point of restoration works in the area is using horizontal anti-sand comb dam to stabilize the gradient of slope and avoid further deepening of stream bed. We can tell from the photographs the results of our 3-year-long effort in installing anti-sand facilities. Take Sul Creek and Baoliku Creek for instance. There were serious landslips and exposures on the slopes before the installation of anti-sand ground sill with lots of debris built up on the stream bed. During the torrential rains, the debris rapidly deposited in the reservoir, hence the extremely feculent water. The installation of anti-sand ground sill facilities adjusted the stream's gradient and eased scouring. With vegetation recovering, the slopes are increasingly stabilized. The debris is firmly deposited on the stream bed, and the water is clearer. Moreover, the landslips are shrinking in size, with vegetation well recovered and slopes well restored. After being treated with anti-sand facilities, revetments, vegetation recovery, and reinforced slope drainage, the landslips in Shalunzai region and Sul Natural Creek had seen an increasingly recovered plantation. The steep streambed, along with rapid water flow that horizontally scoured it, of Baoliku Creek used to result in landslips on both slopes and downward flushing of sediment whenever it was hit by a typhoon or torrential rain. And yet the anti-sand ground sill facilities functioned well throughout Typhoon Wifa and Typhoon Krosa, containing the scours on streambed and landslips on both banks. Similarly, the landslip in Udaunangang had its slopes covered by vegetation and slope foundations stabilized during Typhoon Wifa and Typhoon Krosa, and the slope had not been scoured or exposed ever since. The facts mentioned above indicated the results of anti-sand works and vegetation recovery efforts. The restoration project of Shimen Reservoir's catchment area has shown many results since its start in 2006. The Soil and Water Conservation Bureau also established a number of accesses to disclosed information so as to encourage the participation by the general public and provide a basis for multiple application and discussion, government's policy making, academic research, and educational campaign, for example. The official website of Restoration Project for Shimen Reservoir and its catchment area. Image of the website's homepage. We also include the Management System of Applied Remote Engineering, image of the system's website homepage, the Management and Monitoring System of Soil and Water Conservation, image of the system's website homepage. The main purpose of information disclosure is to inform the general public of the necessity of restoration project and subsequently encourage enthusiasm about the conservation in reservoirs catchment area. The only way to effectively avoid debris flows is to conserve the soil and water, specifically the water source. With such disaster avoided, we can make possible the sustaining development of beautiful mountains and forests and coexist with nature safely. The Soil and Water Conservation Bureau expects your cooperation in maintaining our environment.